Okay, today we're going on to factoring, and there are three types of factoring that we expect you to remember from Algebra 1. The first one, let's change this. The first one is greatest common factor. The second one is a difference of two perfect squares. The third type of factoring is trinomial factoring. And you're actually today going to learn a fourth type of factoring. So these three we expect you to know. And just to give you a little remembrance, a difference of two perfect squares is a squared minus b squared. And that factors down into a plus b and a minus b. Trinomial factoring is when you have something like a squared plus 2ab plus b squared. And you have to break it down into a binomial multiplied by another binomial. This is the type of factoring most students didn't enjoy. The other two are pretty easy. Alright, so I'm going to go through some examples of greatest common factor, difference of two perfect squares, and trinomial factoring, and then we'll hit on the new one. Okay, so here's the first one. If I were to ask you to factor this, then I expect you in your mind to go through these three steps. All right. First step, greatest common factor. Is there something that's in common to the first term and the second term? Yes, there is. It's a 4. Because 4 goes into 8 and 4 goes into 12. And it's an x because x squared and x both have an x in common. So if I pull out a 4x, what do I have left? Well, 4 times 2 would get me 8, and then x times x would get me x squared. Then I have the plus sign. Well, 4 times what gets me 12? 3. And there is no x here because there's only one x here. If you were to distribute this, you should get the same answer you started with. But you're not done factoring. All you've done was do one type of factoring, greatest common factor. You must check to make sure the other two are not present. So a difference of two perfect squares. Sorry if you can hear that in the background. That's my dog chewing on her bone, and it's the only way I can keep her quiet right now. So, difference of two perfect squares. Does your problem look like a squared minus b squared? Nope. So there's no difference of two perfect squares here. Trinomial factoring. Do you have something that looks like a squared plus 2ab plus b squared? Do you have a trinomial here? No. So this problem is completely factored. All right, let's go on to the second problem. Again, we'll go through all the steps. First thing we're going to do is look for a greatest common factor. Is there something that's common to all three of these terms? Once again, there's a 4. 4 goes into 4, 12, 16, and each term has an a. So I can pull out an a. When I write what's left over after I pull out the 4a, careful, there's a 1 here, minus 3b minus 4a. This 1 is often what students forget, because remember, you have to be able to distribute and return the original problem. If I didn't have a 1 there, this 4a would disappear. But we're not done with the problem. We have to see, is it a difference of two perfect squares? Do I see something like a squared minus b squared left over? No. What about trinomial factoring? Careful. There is a trinomial here. So we're going to have to inspect this a little further. I would have to try and break this down. All right, trinomial factoring. Something that multiplies together to get a 1. 1 times 1. Give me something that multiplies together to get me 4a. 4, and a. If I build my bridge and I build my tunnel, I get 4a. Oops, sorry, I don't get 4a. I get 4 plus a. Is that my middle term? No. So this can't be trinomial factored. Let's erase all that. So this is your final answer. All right, moving on. Greatest common factor. Is there a number that goes into 9, 12, and 4? No, there is not. Is it a difference of two perfect squares? Does it look like a squared minus b squared? No, it is not. Is it trinomial factoring? Yes, it is. So trinomial factoring means I have a binomial times a binomial. So the first thing I do is 9x squared. Give me two things that multiply together to get you 9x squared. 3x and 3x. Give me two things that multiply together to get you 4. Well, you've got two choices there. It can be 2 times 2, it can be 4 times 1. We don't know which one it is, so let's try 4 and 1. Now I call this my bridge because it's on top. It's 3x. And I call this my tunnel because it's on the bottom. That's 12x. Can a 3x and a 12x ever get you a 12x? No. If I did 3 plus 12, that gets me 15. If I did 3 minus 12, that gets me negative 9. So if I even had a negative 12 and a positive 3, that's the same thing, gets me negative 9. So there's no way that can work. So guess what? Your guess of 4 and 1 didn't work. How about 2 and 2? Well, let's build my bridge. Let's build my tunnel. All right. Can a 6x and a 6x ever get me 12x? Yep. And now it has to be a negative 12. Well, if I make this negative and this negative, a negative 6x plus a negative 6x does indeed get me negative 12x. So I guess this and this are negatives. So voila, my problem is factored. And that is the answer when I factor that problem out. Now that's the type of factoring that most people didn't like because it took you a long time and it took you trial and error. All right, let's look at this one. Is there a greatest common factor? Well, first of all, you have to recognize the terms. There is one term right here, and there's a second term right here. Is there something in common to those terms? Yes, a y. So I'm going to pull out a y, and I'm left with a 16, the minus, and then I'm left with x minus 1 squared. Am I left with a difference of two perfect squares? Yes, you are. Right here is a difference of two perfect squares. A squared minus b squared. Let's see. This is a perfect square. And this is a perfect square. See the square right there? And there's a minus sign in the middle. So this would factor down into a minus b, a plus b. So that means we take the square root of 16, and it's 4. So put a 4 here and a 4 here. The square root of x minus 1 squared is x minus 1. Because how do I undo a square? I square root it. Then I put a minus sign and a plus sign, and then this y comes down for the ride. Well, I'm going to clean this up a little bit. There's a y here. There's a 4 minus x plus 1. This negates everything in the parentheses. This would be 4 plus x minus 1. This is positive. I'm going to clean this up here. The negative x comes down, and 4 plus 1 is 5. The positive x comes down, and 4 minus 1 is 3. And then the y is sitting out front. There is no trinomial here. I'm only left with a monomial and 2 binomials. So my final answer is y, 5 minus x, 3 plus x. Okay, onward. This is the new one. It's called factor by grouping. And you'll see why it's called factor by grouping in 2 seconds. All right, so the first thing, we still have to go through our list. Is there a greatest common factor? Almost. You see a 5 here and a 5 here, but these don't have 5s. You see A, no. So there is no greatest common factor. Automatically you can skip a difference of 2 perfect squares. It's not in the form of something squared minus something squared, because that's a binomial and this is a quadnomial. And it's not trinomial factoring, because trinomial factoring is only allowed to have 3 terms, and this has 4 terms. So pretty much when you see 4 terms, you almost can go right to factor by grouping. So what does factor by grouping mean? Get rid of all this. It means this. You're going to group terms together. And the easiest way to start doing that is, if you notice, I took the first 2 terms and put parentheses around them. I took the last 2 terms, including the negative sign, and put parentheses around it. Now we actually go back because we have to factor this. Now when I look at this binomial right here, is there a greatest common factor? Yeah, a squared. I'm left with 5a and minus 1 when I pull out an a squared. Right here. Is there a greatest common factor? No. But if you look closely, this is a 5a and this is a minus 1. This is a minus 5a and this is a plus 1. This is completely the opposite here. So you know what? There is a greatest common factor, and the greatest common factor is negative 1. If I pull out a negative 1, I'm left with 5a. If I pull out a negative 1, I'm left with minus 1. Pretty sneaky. Now, I have that term, and I have this term. Is there anything in common to both of these terms? Yes, 5a minus 1. So I'm going to do greatest common factor again and pull out 5a minus 1. And when I pull out 5a minus 1, I'm left with a squared minus 1. See, the a squared from here and the minus 1 from here. Okay, so we did greatest common factor. In fact, we did greatest common factor 3 times. Do you see a difference of 2 perfect squares? I do. Right here. A minus 1, a plus 1, and then 5a minus 1 comes down for the ride. Do you see trinomial? No, I see 3 terms, but they're not in trinomial form. They are not in a squared plus 2ab plus b squared form. So that's your final answer. Okay, let's just try one more factor by grouping. All right, there is no greatest common factor, there is no difference of 2 perfect squares, there is no trinomial factoring. We have to go right to factor by grouping. So factor by grouping, remember, I am just going to group the first 2 together and group the last 2 together. See, I just took parentheses around here and then around the last 2. All right, so now we go back to greatest common factor. Is there a greatest common factor in this first term? Yep, the greatest common factor is x squared. I'm left with 2x minus 3. Is there a greatest common factor here? Yep, the greatest common factor is 2. I'm left with negative 2x plus 3. Ah, but look again. They tried to trick us yet again. If I look at this, these guys almost, that's my dog barking. These almost look exact. They almost look alike, and I want them to look exactly alike so I can do yet one more round of greatest common factors. So I'm going to change this here. I'm going to make this x squared 2x minus 3. I'm going to keep that, but instead I'm also going to factor out a negative. So I really have factored out a negative 2. So negative 2 times positive 2 gets me the minus 4x I'm looking for. And I'll make this negative 3 because negative 2 times negative 3 makes that the plus 6 I'm looking for. And awesome. Now I've got it. Now I can look at my 2 terms again. Here's my first one. Here's my second one. And if I look at that, I realize that I can still do greatest common factor again. What do they have in common? What does the rectangle have in common with the oval? 2x minus 3. So I'm going to pull out the 2x minus 3 from both of them, and I'm left with x squared minus 2. And there it is. This is not a difference of 2 perfect squares. It almost is. X squared is a perfect squared minus for the difference, but the 2 is not a perfect square. So this is your final answer. Yay, math.